Now we're going to learn our levels or scales of measurement. There's actually 4 of them: nominal, ordinal, interval, and ratio. Again, on my notes, I'm not going to write anything. Instead, I'm going to say it. You guys are statistics students, so I expect you to be able to copy what you understand. Again, statistics, it's about doing everything in your own words. So that's why I don't want to write it down. I'm gonna explain each of them. The cool thing is that we have it on video, right? So the cool thing is it's recorded. You can rewind this video as many times as you need to. So the first scale, the first level of measurement is called nominal. Now, what is nominal? These are like categories, colors, names, labels, and even favorite food along with the yes or no responses. Those are examples of nominal label data. Nominal uh, data are not in order. Right? I could ask you guys, what are your favorite colors? Put them in order. Like, is green your favorite color? Um, I expect some of you guys to say yes and no, or some other will say no. Is blue your favorite color? Now, some of you might have choose red, and some of you might have choose green. Now, it's just like a yes or no type of answer, right? Like, but there's no meaning into, okay, those that pick red are better than those that pick green. There's no really difference on those, right? Nominal scale data are not order. For example, like let's think of an example. Let's try to classify people according to their favorite food. Does not make any sense. Putting pizza, some of you will choose pizza better than sushi, right? The order doesn't make sense, right? So that's why we go with favorite or yes or no type of questions. Now, ordinal. Now, this sounds like order. Ordinal. It's similar to nominal scale, but now this one has a big difference. The ordinal scale can be order. Remember, nominal cannot be in order. I ask you guys, for going back to nominal, put in order, or no, tell me your favorite food. Compare sushi with pizza. Which one do you prefer? Now, does it really make a difference who chose pizza and who chose sushi? Not really. Now, in ordinal, it does. Now here, this can be in order. An example of ordinal scale data is the list of the top 5 national parks in the United States. Another example will be using the ordinal scale it's a teacher survey. Let's say I do a survey with the responses to questions about our excellent, good, satisfactory, and unsatisfactory. Let's say I came over and I asked you guys, this statistics class, how do you like it? In my choices, I will give you choices. 1 for excellent, 2 for good, 3 for satisfactory, and 4 for unsatisfactory. Excellent and good, you guys, excellent would be like, oh yeah, I love this class. Good, kind of do. So there's a difference, right? But some of you might choose excellent, some of you might even choose satisfactory. There's a difference between each of my categories. So that's what we call for ordinal. Now, these responses are ordered from the most desired response to the least desired. But the difference between 2 pieces of data cannot be measured. You think this class is excellent. You think this class is good. We know there's a difference, but exactly where? Not quite. So that's what ordinal. Remember, nominal, I cannot put it in order. Ordinal can. Interval is a little more interesting. Interval is similar to ordinal. Okay, so similar to ordinal level because it has definite ordering, but now there is a difference between data. The difference between interval scale data can be measured through the data does not have a starting point. For example, temperatures. I don't know whether you want to see a Celsius or Fahrenheit. These are used in interval. Well, here in Bakersfield we use Fahrenheit. So temperature could be interval. Now, in both temperatures, right, Celsius or Fahrenheit, for example, 40 degrees is equal to 100 degrees minus 60. Now this difference does not make sense, right? Because 0 degrees does not, because in both scales, 0 is not the absolute lowest temperature. So that's what I came in and said, this thing has no starting point for interval. I don't know what's the lowest that the weather can be. Right? For example, 0 degrees in Celsius, 0 degrees is it's freezing, but we can always go below 0, right? We could go negative 10 degrees, we could go negative 15 degrees, or we could go negative 2 degrees. So there's not lowest number we can choose. Same thing with Fahrenheit, right? Weathered. Um, Here in Bakersfield, we don't get that cold, but in other places they do. Minneapolis, a couple years ago, about more than a couple, I guess, 3 years, they got to negative 50 degrees Fahrenheit. So is that the coldest that they can get? No. What's the coldest? I have no idea. I don't even know what negative 50 feels like, but I know it could be colder than that. So interval has no specific 0. So matter of fact, we do it in intervals, right? You guys have heard the word in English class, like groups. Example, your letter grades. Like one of you guys, let's say one of you guys finishes with an 83%, the other one finishes with an 87%. Yeah, there's a difference between 83 and 87, but it's still a B. Now the last one, this ratio, this is very interesting though. Ratios are scaled data, like interval scaled data, but it has a 0 point and ratios can be calculated. So actually grades will be more like ratio. This can be calculated. For example, for multiple choices statistics final, let's say I give you guys test, and then some of you guys get, out of 100, some of you guys get 80, 68, 20, and 92. Okay, so let's say I get some answers, right? Like again, my examples that I'm using are 80, 68, 20, and 92. Yeah, we can say that 20 is lower than 80, right? Whoever got 20, yeah, they got a lower score than 80. And then interesting on ratio, I can even say 80 degrees did 4 times as better as a 20%. So someone that gets 80% or 80 out of 100 did 4 times as better, 4 times as good as someone that does 20%. You guys see my definition there? In weather, I cannot do that, right? In interval, I cannot do that because I cannot say 100 degrees is 4 times hotter than 25 degrees. 25 degrees is cold. 100 degrees is hot. So I cannot say, whoa, just 25 degrees, just make it 4 times as much. No, 25 degrees Fahrenheit is cold. 100 degrees is hot. Interval cannot do that, but in ratios, I can. Let's say somebody that got 25% on a test and someone that got 100% test. So I can just say um, the 100% did better than the 25%. It did 4 times better. That's what we do with ratio. We can compare those. Let's take a look at some examples. Let me take a look at here. I'm going to do 11 examples here. Now, interesting in statistics, I don't expect just the word. Unless I give it to you just a multiple choice, there will be some homework assignments when I will say, all right, just this choice or that choice. I want to see if you guys are getting it. But if I leave it for you to type in the answer, I expect you to back it up, to give it some support. So in my case, I'm going to support this. So indicate which level measurement is being used in the given scenario. Like in my case, I'm going to support it. If I do it as a multiple choice, I could just say, is this nominal, ordinal, interval, or ratio? If I give it as a choices, I'm just checking, did you understand what I mean? If I leave it blank, then I expect you to back it up. Okay, so here, the teacher of a class of third graders record the eye color of each student. All right, if I have a kid with green eyes and I have a kid with brown eyes, I can see a difference, but does it make one of them better? Well, no, this is a nominal level measurement. Eye color is not numbered, right? And so the lowest level measurement is used. So we hear the teacher of a class of third graders records the letter grade for math for each student. Okay, so I'm looking at the grades now. Now this is ordinal. Ordinal because the letter grades can be ordered with A as high as an F, and then that's the lowest. However, the difference between these grades are meaningless. An A and a B grade could be separated by a few or several points, and there's no way of telling if they're simply given a list of letter grades. So this will be ordinal. Let's take a look at 3. The teacher of a class of third graders record the percentage that each student got correct in the last science test. Okay, so I'm looking at percentage. Okay, think about it. Is there a lowest value that they can get? And if there is, that's ratio. Mm, Is there, what's the lowest on percentage wise? What's the lowest score that you can get? Well, obviously 0, right? There's no negative answer. So there is a lowest value. Is there a highest value? Yeah, 100%. Okay, so there is a lowest. So this case, this will be the ratio level of measurement. So this will be ratio. The numbers have a range from 0 to 100, and it makes sense to say that one score is a multiple of other, right? Somebody gets 10% and somebody gets 50%. I'm going to say the 50% did 5 times better as well as the 10%. You see how I'm doing ratio there? I'm comparing one to the other, but I'm saying how many times better. Remember for weather, I said weather is not ratio because I cannot say 100 degrees is 25 degrees just 4 times as much because I said weather 25 degrees is cold, 100 degrees is hot. But percentage on the test, those I can do. Now here for number 4, a meteorologist compiles a list of temperatures in degrees Celsius for the month of May. So my values will be whatever the weather is for May. And then I expect some numbers, right? Now this will be interval level measurements. The temperature can be ordered, right? I can say this day was hotter than this other day. And we can look at differences in the temperatures. However, a statement such as a 10-degree day is half as hot as a 20-degree day is not correct. So that is not a racial level. It could not be racial level because I cannot say, this day is twice as hot as the other day. So that's what's not racial, but I can put it in order. And so that will call that interval. Take a look at number 5. This person compiles a list of temperatures in degrees Fahrenheit for the month of May. Well, it's the same thing as that one, right? I'm using Celsius here, and I'm using Fahrenheit here. It's not ratio because I cannot say a day with 25 degrees Fahrenheit, like remember 25 is cold, and a day with 100 degrees, well, 100 degrees is just like the 25 degrees, just 4 times as much. No, it doesn't work like that. So it's not ratio. This is also interval. Take a look at number 6. Person compiles a list of temperatures in degrees Kelvin for the month of May. Now, be careful, careful. Even though this is another situation involving temperatures, this is ratio level measurement. The reason why is that because the Kelvin scale, probably you guys are not familiar with it. If you guys want to learn, you can always Google it. The Kelvin scale does have, an absolute 0 point, which we can reference all other temperatures, right? A 0 degrees, a 0 for Fahrenheit, a 0 for Celsius is not the same, right? There's for Kelvin, there is. So be careful on that one. There'll be some words that you guys are not familiar with. You can always Google it. All right, question number 7. Like I said, this is my practice. There's a film critic that lists the top 50 greatest movies of all time. So I asked the person, what are the best 50 movies? And this person gave me a list. Maybe not the list that I would choose, but this person does a list. Now this is ordinal, right? He put him in order. This critic put him in order. So it's an ordinal level measurement. Now the rankings are ordered from 1 to 50, right? So he put him in order, but there's no way to compare the difference in rankings, right? The movie that he chose for number one could be better than the one that he chose for number two by only a little, or it could be way, way, way better. Depends on the critic, right? There's no way to know from rankings alone. If I ask you to give me the best 5 movies, there's no way I can say your number one is better than the number two. You might tell me I like it better because it was more funny, but I cannot really tell. Now, number 8, there's a car magazine that lists the most expensive cars for 2012. Now, this one, prices can be compared at racial level. Now, this one, because things can be compared. Let's say you buy a car for $20,000 and you buy a car for $100,000. Instead of buying the expensive car, can you have bought 5 of the cheap cars? Yeah. So that would be ratio. Now, number 9, the roster of a basketball team lists by the jersey numbers for each player. So you see how in sports they tend to have numbers. So you give me the numbers, and then obviously with the name included, but I'm listing them by the name of the jersey. Now, the jersey is just a jersey, even though it's a number. So even though there are numbers associated with this data set, the numbers serve just for alternate forms of names, right? Instead of calling them by their name, I'm calling them by their jersey number. So even though it's a number, there's no relationship among them. I cannot just say whoever has jersey number 4 is taller than whoever has jersey number 2, right? In jerseys, a number is just a name. So ordering the jersey numbers makes no sense. So there's no reason to do any arithmetic. We cannot do any math with these numbers. Now, so this would be nominal level of measurement. Nominal, because I can put them in order, but the first person listed, I cannot say it's better or worse than the second person listed. They just put it in order by the jersey numbers. All right, question number 10 here. A local animal shelter keeps track of breeds of dogs that come in. Okay, so there's breeds of the dogs, right? Now, this is nominal due to the fact that dog breeds are not numeric. So I cannot just come and say, uh, this dog is twice better than this one. And I can't, right? It's not even a numbered. So this will be nominal level. Now, a local animal shelter keeps track of the weight of the dogs that come in. So now I'm looking at the weight. Now this will be ratio, right? 0 pounds is the starting point for all the weights. There's no weight that is a negative numbered. And let's say I have a 5 pound dog, is 1/4 the weight of a 20 pound dog. So see how I'm relating the weights? I can just say, let's say I have a dog that measures 5 pounds and a dog that measures 10 pounds. I can say the 5 pound is half the size of the 10 pound. Because yeah, I can compare. So that would be ratio. This is the ratio level of measurement.